death toll in the powerful twin earthquakes in Venezuela crosses 1700, the subject of Earth's plate tectonics, responsible for a vast majority of earthquakes, has again come under focus. What was striking about the Venezuelan earthquakes is that the two of them were more than 7 in magnitudes on the Richter scale and occurred within 1 minute and 5 kilometers of each other. To understand the forces at work in such devastating movements of Earth's plate, MCR spoke to seismologist Suzan Lee. She is a professor at the Northwestern University in Chicago who studies the dynamics that govern planet Earth and other terrestrial planets. Her research is data driven. Apart from quakes on Earth, she also studies quakes on Mars. Welcome to Mindshare Reports, Professor Lee. It's a great pleasure to have you.
It's my pleasure to be here.
You know, the twin Venezuelan earthquakes with magnitude 7.5 and 7.2 occurred within 1 minute and 5 kilometers of one another, as you have pointed out. You also said that when two earthquakes with this magnitude happen on the same day, it's even less common that they happen within such close space and time vicinity. What do you deduce from that in terms of plate tectonics?
Oh, well, that's a good question. All earthquakes are the result, maybe 90% of the earthquakes are the result of plate tectonics and occur on the boundaries between two different tectonic plates. However, exactly when and where those earthquakes occur, right, is kind of very difficult to know and predict. And so over like geological time periods, we know that a certain amount of earthquakes have to occur to accommodate the relative motion that the two tectonic plates need to cover, to remain on their steady paths. And so that translates in a certain number of earthquakes, a certain distribution of earthquakes. And so, but that doesn't say anything about when exactly those earthquakes happen in time or relative to one another in time and or space. So I don't think the fact that those two earthquakes happened within 5 kilometers and a minute from each other says anything about plate tectonics, just confirms what we already know from all the other earthquakes that happen on plate boundaries.
But quakes of these magnitudes happening so close to one another, as you pointed out, it's not that common. Now, as a seismologist, does it raise a red flag for you in any way at all?
Oh, I see. Well, those two earthquakes would have had to occur in those two places at some point to accommodate the plate motion between the relative plate motion between the Caribbean plate and the South American plate in opposite directions. The fact that they occurred within a minute of each other is more, yes, it is very rare, but it is not alarming in a way, in the sense that both had to occur anyway, and they randomly decided to occur, or they didn't decide it, but they randomly happened to occur within 1 minute from each other. And it's not necessarily that alarming because, like I said, they would have had to occur anyway at some point.
Do you believe as a seismologist that the science of seismology inherently is difficult one because it's not that easy to predict earthquakes? How do you as a professional seismologist look at this challenge?
Yeah, so there's a lot of or professional seismologists that study earthquakes that would really like to better understand how to predict them. And then there's seismologists like myself that actually don't specifically study the earthquakes themselves, right? So I know a fair amount about the earthquakes, but I mostly study the seismic waves that they generate and what they tell us about the tectonic plates, for example. However, back to the earthquakes themselves. So we are getting closer to forecasting the frequency of earthquakes. And one of the things that is relatively less complicated to predict is when aftershocks will happen of a certain main shock of a certain magnitude, right? And there's empirical laws that describe those, and there are statistics that can be applied. And so we know that when an earthquake of a magnitude 7.5 happens, there will be aftershocks, and they will decay over time in their number. And the largest magnitude aftershock is usually at least one magnitude point lower than that of the main shock. So, in some ways, right, the magnitude 7.5 would normally be regarded as an aftershock of the magnitude 7.2 earthquake that occurred first,
I see.
except that its magnitude is very unusual for an aftershock, and that's why it's considered an equal or larger main shock to the first one.
Oh, I see. I didn't
Yeah.
realize that the 7.5 was an aftershock.
Well, it technically isn't because its magnitude doesn't fit the
It's
bill,
higher, right?
and that's why we call them a doublet. But it's
I see.
semantics at this point.
Yeah.
Yeah.
Somewhat speculative questions. Let's say if you were a Martian, if you were a Martian studying Earth as a planet from a geological standpoint, what
Yes.
would such quakes tell you about the planet? I know
Well, it
it's
would. It,
speculative, but I'm interested to know.
Yeah, well, it's really funny that you ask that because I have actually also studied Mars quakes in
I'm
recent
aware of that,
years.
yes.
Yeah, yeah. And so on Mars, there's no plate tectonics. So
Yeah,
yeah, and so it's not entirely clear why Mars quakes occur on Mars. We, developed our own hypothesis about the number of Mars quakes that we detected there, but we really don't know. And that is also the same for some earthquakes on Earth, namely the 10% of earthquakes on Earth that are not caused by plate tectonics. So if I were a Martian and looking at Earth, I would notice the high frequency of earthquakes that form, lineaments around large chunks of the Earth's surface that don't have earthquakes. And I would immediately think of, hey, looks like the surface of the Earth is split up into different chunks that move in different directions relative to each other, and the friction on their edges is causing these earthquakes to occur from time to time.
right. So, but intuitively, it would seem as if you do need plate tectonics to have earthquakes at all. I mean, it's so obviously that's not true, right?
No, earthquakes, Marsquakes, they can occur, and also lunar quakes can occur for any number of reasons. Um, but it is true that plate tectonics is a very, very effective generator of earthquakes, and it generates way more earthquakes in a shorter amount of time than any other processes that we know about.
I see. Would you care to explain how a Mars quake or a lunar quake might occur without plate tectonics? What are the forces at work here?
Well, like I said at first, we don't really know for the Mars quakes, but we know maybe a little bit more about the lunar quakes, and some of the deeper ones that occur on the moon are the result of tidal forces that the Earth exerts on the moon.
I see.
Yeah.
Okay. You have pointed out in your background that annually about 15 earthquakes of 7 plus magnitudes occur every year.
Yeah.
About 150 or so of 6 or higher magnitudes, and about 1,500 of 5 or higher. Now, essentially, we live on a planet that is in a permanent state of flux, going by the number of quakes that happen practically every day. Is there an expiry in terms of geological timeline when earthquakes might cease? Or they are going to continue as long as the planet lives?
Well, definitely the earthquakes that occur inside tectonic plates, in the lithosphere of tectonic plates, like they do, like 10% of the earthquakes on Earth, like they do on Mars, like some of the quakes on the moon, those will likely continue as long as there is a lithosphere with a crust, right, that is cool and brittle. Will the earthquakes on the edges of tectonic plates continue? Well, that depends on how long plate tectonics will continue. And the reasonable estimations that we can make about how long plate tectonics will continue, are likely going to be informed about when did plate tectonics begin in the geological past. And that is something what Earth scientists are not entirely in agreement about, right? And in part, that is because there is evidence in the geologic record that there might have been processes like plate tectonics operating quite early, like billions of years ago, but there's not enough evidence to conclusively draw that conclusion or to definitively draw that conclusion. And so that debate is ongoing. But there is not an obvious reason today why plate tectonics should cease in the future before the Earth itself ceases to exist.
Oh, I see. That's interesting. You mentioned lithosphere, which basically floats about a molten and moldable layer called asthenosphere. I mean, I'm saying it for my viewers' benefit. I'm not informing you. It would be. It's not my temerity to do so. But what will happen if and when the molten layer becomes rigid? Do you think that's the end of plate, or you think it will not ever become rigid?
No, I'm saying it already is rigid. Like,
oh, I see. Okay.
Yes. So you are in some ways right by saying that the lithosphere is floating on the asthenosphere, but but the asthenosphere itself is rigid. The entire mantle, down to the core mantle boundary, is in principle rigid. But because as you go from the surface down into the Earth's interior, the temperature is rising very, very fast as you go through the lithosphere. And then when you reach the asthenosphere, it is like maybe around 1200 degrees, 1300 degrees Celsius. And then it starts to increase a little bit more slowly until you get to the core mantle boundary. But also the pressure increases at a fairly steady rate. And so because that rapid increase in temperature, that makes the rocks softer. So as you get towards the bottom of the lithosphere, you'll still find solid rocks, but they're hotter and softer than those in the lithosphere, and therefore a bit more easy to deform, like tar or asphalt on a road. Right? So that is still a solid, but it is a deformable solid.
I see. Okay.
Yeah, but as you go even deeper than the asthenosphere, then the pressure takes over and increases the rigidity. And that's why the asthenosphere is the most deformable layer between the lithosphere above it and the more rigid mantle beneath it. And that's why the lithosphere can move relative to the rest of the mantle. Oh, like in the asthenosphere is sort of the jelly that makes the relative movement happen, but it is still a solid. Sorry, jelly is not a good word because jelly is not a solid, but it is, the asthenosphere is solid.
Okay. That's a good piece of information. I didn't realize that. Coming back to the Venezuelan earthquakes, do you think that now that energy has been released, in a sense, the plates have done what they wanted to do? Do you expect something of this magnitude happening anytime soon, or again, that cannot be predicted?
Okay, one can forecast how many of those earthquakes can occur on a certain plate boundary given the relative motion between the two plates, right? And if you look at that, it will predict that these kinds of earthquakes occur less frequently than, for example, on the western side of South America, where South America is sort of colliding and overriding the subducting Nazca plate. And so therefore, I'm going to say that these earthquakes probably will happen again, right? But the time periods we're talking about could be tens to hundreds to thousands of years. Well, not thousands probably, but more like tens to hundreds of years. But they can strike at any time in that period. So, yeah. So just the fact that these two earthquakes happen doesn't mean that we won't have future ones. There will still be future ones.
Plate tectonics as a science came into being somewhere in the 60s.
Yes.
People believe that what is quantum mechanics to physics, plate tectonics is to geology.
Yeah.
Do you think we are now at a stage where we understand the most important aspects of the science, or you think we have barely scratched the surface?
Oh, so there's a lot that we understand about plate tectonics, But there's also still a lot of questions about the forces that are driving it and the forces that are modulating it. And then also about the different scales of deformation that occur in the mantle and in the asthenosphere and at the bottom of the lithosphere. And there are questions about how to change the boundaries between plates, how to create new plates, what happens to them after they've subducted to sink back into the solid mantle. And when I'm talking about sinking and upwellings from the mantle that form new lithosphere at mid-oceanic ridge boundaries, I am talking about that sort of convection on geological timescales, not because the mantle is fluid or liquid, but because as a deformable solid, it can change the flow of the material on geological timescales of hundreds of millions of years. Yeah.
I see. Given the primal nature of plate tectonics, one can safely say that we really will never have an antidote against it. It's that's what Earth is, right? I mean, we are at
Yeah.
its basically Earth's mercy when it comes to things like cyclones or heavy rains or
Yeah.
earthquakes. So how does one work around that in your judgment? Because you've been studying it for quite some time. Are there tips that you might offer seismically active zones so that
Mm-hmm.
they might consider?
Yeah. Okay. So good point, right? So one might want to avoid the earthquakes associated with plate tectonics because they can cause damage and devastation. However, one of the things that earth scientists agree upon is that one of the main ingredients on Earth that allows the occurrence of plate tectonics to happen is the same ingredient that allows life to exist, right? And
Exactly.
that, yeah, and that is water. And so, in some ways, we can't escape it because the ingredient that is critical for life and us to exist is also what is allowing plate tectonics to exist. So we are debating exactly the role of water is in plate tectonics, but I have my own ideas and other people have other ideas, but we agree on the fact that water is important. So it is very difficult to escape plate tectonics if you want to live on a habitable planet like Earth, an habitable terrestrial planet. So then the question is what to do, right? Because where the earthquakes occurs on the edges of plate boundaries, and those are usually also very interesting, right, for human endeavors because they are near a shoreline,
Correct.
or and so sometimes you can't necessarily choose, right, to live away from all hazards. There's always some hazard, some natural hazard that exists and that gets exacerbated if we don't respect it enough and if we put our infrastructure in a place where we shouldn't, or we shouldn't put it there in the way that we do, right? So you don't want to build homes that are vulnerable to earthquakes that can easily collapse, in a seismically active zone near a plate boundary. Whereas you would want to build exactly those kind of homes, like in the Midwest, where they can withstand tornadoes, right?
Right.
So if you are in the Midwest, you want to build a house that can withstand tornadoes, but it might not withstand earthquakes, and vice versa. When you live on the plate boundary, you might want to build a house that withstands earthquakes, but not cannot withstand tornadoes as well. So you have to like weigh the pros and cons of the risks, right? The hazards that exist around you, and then you need to like do your best, I guess, to build infrastructure that is minimally vulnerable. And you can never avoid all hazards and all risk. And then prepare, like what happens if and when an earthquake strikes, and go through scenarios, right? And have an earthquake kit ready. And then if you do feel it shaking, right? If you are near an earthquake in inside a tectonic plate or at the edge of a tectonic plate, there is a US meme that is being very effective. It says drop, cover and hold on. So you drop to the floor, you find cover under a sturdy desk, for example, and you hold on to a leg of it so that it doesn't shake away from you, for example.
I see.
And then once the shaking is over, it is best to go outside and to assess. Okay.
Just last couple of things. One is, of course, of the 7 major plates on this planet, which one do you find most interesting? I know it's perhaps a silly question to ask, but do you find anything which grabs you more than the others?
Well, there are several that are interesting in their own right. In fact, all of them are very interesting, actually. But I am currently very interested in the Nubian and the Somalian plate, which are the 2 future parts that the current African plate might be splitting into.
Right.
But I'm also very fond of the North American plate because I've studied it intensely since my PhD, and it has shown me some structures that I feel tell us how exactly water is driving plate tectonics. Yeah.
Okay. And finally, to conclude, I'm quite curious about your work on Mars quakes. How do you go about gathering data on Mars quakes, and how frequent are Mars quakes?
Yeah. So Mars quakes are much less frequent. Just like on Earth, the earthquakes that occur inside a tectonic plate are much less frequent than the ones that occur on the edges of the plates. Now, luckily, I didn't have to go about collecting the data on Mars, right? That was a collaboration between NASA and the European Space Agency. And they essentially sent a spacecraft to Mars. It landed there. It deployed a broadband seismometer that was very, very sensitive. And it started recording seismic vibrations and seismic waves. And it got maybe 2, 3, or 4, even 4 years of data were collected, maybe 3. And that data was immediately made available to the public, including researchers like myself and my student, with which I studied that data, right? Because it is funded by NASA and ESA. And so they wanted to share this with everybody. And so we started working on this data during the COVID pandemic, when the student that I was working with had actually hoped to work in an analytical laboratory, but then they were closed. And then she was looking on something that could be done on a computer. So what's better than using data from a distant planet and start analyzing it on the computer? So that's how we got started.
No, my basic interest is one of the things I'm very curious about is in terms of magnitude on the Richter scale that we measure here.
Yes.
Do Mars quakes have intensity that is comparable, according to you?
No, they're a much smaller in magnitude, and that is very likely because they occur on smaller faults. When you have plate tectonics, you have, in some ways, a giant fault surrounding each tectonic plate. So, yeah, a lot of slip can happen all at once, and that is what determines the maximum magnitude of earthquakes or quakes that can occur.